Concentration, that's the measure of thinking of how much solute is per a solution, per solvent. So thinking of how concentrated orange juice can be. If you wanted to be really concentrated, you would have more pulp of the orange. If you wanted to dilute it more, you would add more water. So concentration, which we can think of, one really, really common term is molarity, is the moles of solute over liter of solution. So for a concentration, you're looking at solute over solution. So how much salt you have in salt water, how much sugar you have in your sugary coffee, and etc. Now let's look at this first question to bring that into practice. Calculate the molarity of 31.7 grams of magnesium sulfide in 947 milliliters. So we're given grams of magnesium sulfide. And we want the molarity, so we want the concentration. So I'm given here 31.7 grams magnesium sulfide. And I'm also given 947 milliliters of solution. And I want molarity, which is mole solute, which would be magnesium sulfide, over liter solution. So let's look at what we got. Well, I have my volume of solution, so I can convert this to liters, which would be 1 liter divided by 1,000 milliliters. And that gives me 0.947 liter solution. So I have my one part of the molarity, but I need moles. Well, since I'm given grams, I can convert to moles using molar mass. So I calculate the molar mass of magnesium sulfide, which is 56.38. And remember, molar mass is always given to you. You can look at the periodic table, look at the mass of magnesium, look at the mass of sulfide, and then add together. It's around 22 plus like 32 something. That gives you 56.38. Now, because you want moles, you got to get rid of grams. So 31.7 grams times 1 mole over 56.38 grams, which gives you 0.562 moles. Now, because you want molarity, you go back down here and plug everything in. 0.562 moles over 0.947 liters, which is 0.5937. We want 3 sig figs, so I'm going to say 0.594, big M for molarity. Now let's look at the next problem. The next problem says if 4.85 grams of copper nitrate is dissolved in water to make a 0.260 solution, what is the volume in milliliters? So given here, 4.85 grams of copper nitrate, okay, and 0.260 molarity. Now, I always like to say what molarity is. It's 0.260 moles over liter. Now, we want volume in milliliters. So I'm basically trying to get this right here. So I have to cancel out that moles and need to use the grams. Well, in order to do that, I have to convert to moles first, just like we've done already a lot. So I take my 4.85 grams copper nitrate and divide by my molar mass, which is 187.56 grams. Then if I do that math, I get 4.85 divided by 187.56 is 0.0258 moles. Now, because I want the volume, I now will cancel out the moles to just get my liters. So 0.0258 moles. And now I flip my molarity. Since I want liters, that goes on the top, and 0.260 moles goes on the bottom. This cancels out my moles and leaves me with a volume of 0.09945. And I wanted milliliters, so one more step. Which then will be to multiply that by 1,000, 99.5 milliliters. So the difference between the first two problems, in the first one, we were looking for molarity. So we had to convert to moles and then divide by the volume to get the concentration. In the second one, we were given molarity. So it's always good to say what big M stands for. Big M is always moles over liter. So if you have moles, then you can find the liters, or vice versa. If you have liters, you can always get moles. Let's look at the next one. How many milliliters of 11.0 molar hydrochloric acid are needed to prepare 630.0 milliliters of 1 molar HCl? So you're given here molar HCl. You're also given 630 milliliters and 1 molar HCl. So you have the same exact compound and you're just diluting it. So this is your M1 and you're asking how many milliliters, so you want your V1, are needed to prep 630 milliliters, so that's second volume, of 1 molar concentration, second molarity. So here you use a dilution equation. You only use the dilution equation when it's the same exact compound with water, not HCl plus NaOH. That is a reaction. It's only ever if it's the exact same compound because they're not reacting and it's a 1-to-1 ratio. Now, you're looking for V1. So you divide both sides by M1, just very similar to different equations we've done before, and isolate. And then you plug it all in. So you will find that you have your M2 is 1 molar. And you can leave your milliliters the way that it is because it doesn't specify that you need liters. And then divide by the molarity of 11. And your molarities cancel. You'll be left with a volume unit of milliliters, which is what you want. 1 times 630 divided by 11 is 57.3 milliliters. So here we weren't isolating anything in the molarity. We were given molarity and a volume, but we were given 2 molarities in 1 volume, wanting to find another volume. So it's basically asking to make a 1 molar hydrochloric acid solution, which is way less in concentration than 11. But you have 11. So how much volume do we need to dilute it down to 1 molar? And you figured out, starting with just taking 57.3 milliliters of 11 molarity of HCl, then taking it up to 630 will dilute that down to 1 molar. You can always use dilution equation when it's the same exact